Hotep, Jambo, Nangadev, boa tarde. Kumari Kurpo, Kenoba. So, I am Dr. Marcelin Ninidabo, an African from Ziguinchor in West Africa, Senegal. So, I am a PhD on control systems and also an engineer and a technician in automatic systems, or automation if you prefer. So if you want to download my PhD thesis, it is here. You will follow this link. And just to share with you that I am also a consultant engineer in industry and an independent researcher. To reach out to me, you can write to this email, okay, contact@daboacademy.com. So I have been doing these last months some videos about my discoveries that I have introduced. So I invite you, if you don't know yet, please go and check my channel, Dabo Academy, through YouTube. I will be happy to present you second order dynamical systems or ordinary differential equations, as you can see. And I will introduce some discoveries that I have made, and I will be talking about Dabo's numbers and framework. So Dabo's numbers because I have discovered a new kind of numbers for second order dynamical systems, and I propose a framework in which I present some representations of this discovery. So now let's go in the subject. Just to let you know that my book is finally available. This is a French version. For the moment, it is the only one which is available. So please order yours to prevent a lack of book. Okay. So if you want to order one, you can scan this QR code here. And then you will be able to order your book, okay? And you can share it with your friends, brothers, sisters, etc. If you wanna watch some videos that I have presented through my YouTube channel, you will be able to go through this QR code also, and then to scan and discover some videos of presentations that I have made these last months, talking about very important subjects. And I'm sure those subjects will give you another vision of dynamical systems. So let's go for this presentation. Consider that you have a dynamical system, second order ODE. ODE, of course, stands for ordinary differential equation. And then from here, you have the characteristic equation, and it will give you the discriminants that you have here. So three cases are presented in general mathematics. What you have is the first case is, for example, this one for a delta that is equal to 0. You have for your characteristic equation one double solution that is given by this expression here, and then the solution of your differential equation is given by an affine function of time times the exponential of alpha t. In the second case, when delta is negative, you have two complex conjugated solutions with the beta that is given here, okay, and beta is given here, and then the alpha that is always this one, okay? So alpha will remain the same for all of the solutions of your characteristic equations that you have here, right? And then I was saying for the second case, for delta that is less than 0, what you have is a function, a trigonometric function, okay? A circular trigonometric function times the same exponential as you can see it here, okay? And then for the last case, for which the delta is strictly greater than 0, what you have is R1 and R2 that are two real numbers that you can consider, and they are most of the time presented like this, where you have for the solution y of t equals c1, a constant, exponential of r1 times t, plus c2 exponential of r2 times t. This is what you have, and this is the expression that is most widespread in the resolution of this kind of equations. So, of course, for this, what you have is alpha that is equal to this expression and beta that is equal to this expression. So this yields, if you check it like that, a representation in a framework that is given like this for these solutions R1 and R2 here. You will have an alpha that is positioned here and R1 that is here, because all the elements are strictly positive. I mean, all the coefficients AE in the ODE are positive, and then when you consider the beta here, it is also positive because delta is positive, and then all the expression remain positive, and then you have this representation in a classical real framework. So, exploring these ODEs and doing contemplation of results yields me to another way of seeing things, because it shows me its efficiency that I have presented in my book. So, for your information, English version is coming, but not yet ready for the moment. I'm sorry for that. So, if you consider this expression, this framework here, you can see that it is relative to this expression, and you cannot have a kind of parallel between this first result, this second one, okay? Because you see that there is an exponential here, and also an exponential here. So why don't you have an exponential here? That is a big question. So we have solved this by revelation, and I will show you how, okay? So now going from here, okay, what you have is this one. Okay, so we have seen previously that when you consider this delta, the solution is this one. You consider this value of delta negative. For delta negative, you have this solution. And then now, for the delta positive, I propose a new way of seeing things. This third case, okay, for this third case, if you addition the alpha and beta, or you make a subtraction between alpha and beta as written here, you will have this solution. And this solution will never let you see that there is a hidden expression of the exponential of alpha t inside this expression. Okay, and this way of writing the solution is very, very important, and it is thanks to this way of writing the solution that I have introduced and discovered that there exists in reality for systems of second order, okay, for ODEs of order 2, only one and unique time constant that is expressed by this alpha that you can see, okay? And you can watch another videos of mine in my YouTube channel where I explain in details this expression. But to arrive at this result, it was revelation, but it was also taking time to make contemplation, a deep contemplation on these expressions that I had in front of me. This is why I introduced a number that is gamma equals 1, or I can also take gamma equals -1. And then this gamma will not let you in reality to add alpha and beta. So when you have the solutions of the characteristic equation for which the delta is positive, you have two real numbers, but these real numbers in reality are not real numbers that you should add. Why? Because as I shown it previously, if you add them, you will just have the expression that is here alpha and you have R2 here, R1 here, and R2 on the back. And this in dynamical systems, as you know, this will allow us talking about fast pole and slow pole, and then you will make a kind of compromission by reducing, by saying that, okay, I let, because the fast pole, I will not consider it, and I will remain also always with the slow pole. Okay, but as you know, fast and slow are notions that are relative. Okay, so from here, what I do when I introduce this number gamma, I don't let the two make the addition of alpha and beta. What I do is I separate alpha and from the beta, and by doing so, I can write this expression to recover the exponential of alpha t and hyperbolic trigonometrical solution here that you can observe. And this is a very important way of seeing things. So if you separate this and this, how now, which framework will you be using to represent these numbers? This is very important. This is why I introduce the framework, and this framework, I just call it DABO's framework. Okay, and it is here, as you can see, it is here. So for the trigonometric, for the circular trigonometric world, what you can see is that for this solution, so these solutions just come for differential equations that you have classical ODEs in physics, where you have S double dot plus 2 times xi omega n S dot plus omega n square S, that is equal to 0. From there, you have these solutions here, okay? And the representation of these solutions is in this framework, where you have the real part here, because these are complex numbers, and the imaginary part in the vertical here. And this is why you have I here, and also I here, sorry, okay? This is what you have in normal time. And then you can see that the first part of this number always is represented on the horizontal axis that you can have here. And this part of the number, that is the imaginary part, is represented on the vertical axis. Okay. And for this, I will not be making a comment. It is just an affine function, as you can see here. But for the delta positive, meaning that when the xi damping ratio is greater than 1, what you can have here is that you have this framework that I call the framework of Dabo, as said, or meaning that of mine, and I introduce it with the Dabo numbers, okay, with the gamma that is equal to 1, and I say it again. This introduction of gamma here is just to let the reader do not make a confusion, to make an addition between this part of the number and this part of the number will project you on a flat space. Okay, it will be for you a flat space where all the numbers R1 and R2 will be only here. But if you represent like this, what you will have is that this number, you will have it here, okay? This number also, this part of the number, you will have it here, okay? And then these parts, okay, will be here, right here and here, okay? So you see that it is quite the same framework as the complex framework that we have here. This is why I have introduced the term real conjugated numbers. Because as complex conjugated numbers here, what you have, real conjugated numbers are such that they have some specific properties. And then those properties, as you can see, are shown here. Okay. So recall that for complex conjugated numbers, what you have z equal a plus ib, z bar equal a minus ib, and then for the sum, you have the result, product, difference, module. Okay. And then for here, for the Dabos numbers, the real conjugated numbers are given here. I consider just the z1 and z2 belonging, of course, to real numbers. And then the gamma that I have introduced that is equal to 1. When z1 is equal to a minus gamma b, z2 is equal to a plus gamma b. And then if one of them is a solution of a characteristic equation of with real coefficients, the other one also is a solution. Exactly the same for complex conjugated numbers, as you can see here. It is written in French, of course. And then the sum, if you do the sum z1 plus z2 of two real conjugated numbers, you have the same result as for complex conjugated numbers. If you take the product, you will see that there is kind of conjugation, because here it remains square of cosinus plus square of sinus equals 1. And then here it remains hyperbolic cosinus square minus hyperbolic sinus square, that is equal to 1 also. Okay? And then here what you have is the difference. You have the difference between the two numbers. It is equal to minus 2b. This is why I was saying that I could take gamma that is equal to minus 1. In reality, we can take it in order to be, to have a kind of parallel between this difference that is equal to 2ib. Because I here is an imaginary number. And the gamma here will be an hyperbolic number, gamma equal minus 1. Okay. And then for the module, you have the same. So to resume, the difference is only visible here. Okay. You have a square plus b square. Okay. And then you can see that if gamma equal minus 1 here, what you have is this case. If gamma equal 1, okay, you have this case, for example. Sorry, it is always the same case. Okay. And then here, if we consider gamma equal minus 1, in this complex conjugated number, you will have 2ib for the difference. And for the real conjugated numbers that I have introduced and called Dabos numbers, what you will have is 2 gamma b. Okay. So this is what I wanted to share with you. And without this vision, it wouldn't be possible to see that when you are manipulating second order dynamical systems, it is possible to see them as a dynamical system that is living in three different worlds. When delta is less than 0, you have the system is lying in circular trigonometry, enveloped by an exponential function, as you can see in the result. When delta is equal to 0, you have a system living in an affine world, always enveloped by the same exponential. And then finally, when delta is greater to 0, what you have is a system living in an hyperbolic world, always enveloped by the exponential function. And then this exponential function if you see it in a dynamical way, you will see that there is a real parallel between a system of second order, of first order, that can be written as this one, y of t equal a constant that I will be calling C0 times an exponential of a certain t divided by tau here. Okay, so if you look at this expression, of course, you can see that this is a constant, C0, times an exponential. And then you can see that here you have an exponential, here you have an exponential, and here you have an exponential. This is why, thanks to this contemplation of these results, I have introduced that for second order dynamical systems, in reality, there exists only one and single time constant. That is a double of what I have defined and called as a relative time constant of my second order dynamical systems. So for more details, I invite you to refer to some different other videos that I have presented. I want to thank you very much for your attention, and then remind again you that you must buy this book. You must order this book as fast as you can, because it will bring you very new results and very interesting results. So thank you very, very much for your attention. And just to share with you something very important before I let you go. Be aware that from this result, the way you write some results in mathematics will hide you some important results, can hide you some important results that can change the approach and with very important consequences in how we implement algorithms, how we save energy of our world. It's very, very, very important. If you are also working as a researcher, sometimes I invite you to take time to look deeply on some results that you are facing to. It can be some things that you take always time to write. Every day you write them, every day you write the same thing, but never take the time to contemplate deeply the results. Okay, so I really invite you, as I have done it, to take time to meditate on the results that you can see and to go deeply in the contemplation of the results that you have. This is what I wanted to share with you, and thank the Holy Spirit to have revealed this to me as a discovery. So notice that there is new numbers, new real numbers, as I have introduced here, as you can see. And also notice that there is a new framework that should be taken into account to represent this kind of numbers. And all this, I have baptized them, calling them Dabo's numbers, because I have discovered them, and Dabo's framework, because I have discovered this. I have never seen this somewhere. But in your research, if you can show me the proofs of this, I don't have any problem. But look, this is the result I wanted to share with you. So again, don't forget, order your book very quickly. Please order your book, support the job that I'm doing. And again, thank you very, very much for your attention. Enjoy your research, love what you're doing, and enjoy yourself. Keep on doing yourself. Thank you again for your listening, and please share this video, support my channel, like, and then see you soon. Bye.